Hi everyone and welcome to this video on factorization of polynomials. I'm going to break this into three parts. So the first part is going to be looking at the factor and remainder theorems. The second part is going to be actually doing the factorization. And the third part is going to be looking at the sum and difference of two cubes. So to begin with, we have this problem. Find the remainder when x cubed plus x squared minus 5x plus 6 is divided by x plus 3. Now the way that we would do this problem is we would put the x plus 3 here. And basically we would run through our long division process. So I'm going to do that just really quickly. So that's going to give us x squared there, which gives us x cubed plus 3x squared. We take that away, leaving us with negative 2x squared minus 5x plus 6, which then gives us minus 2x there. So we get negative 2x squared minus 6x, we take that away, and that gives us x plus 6, which then we get just 1 there, so that gives us x plus 3, and we take that away, leaving us with 3. So this is the remainder here. Now we don't want to have to go through that every single time that we do one of these problems, and there is a more efficient way to actually go about solving it. So what someone much more intelligent than myself recognized was that basically there's a link between this number here and this number here. Not that they are the same, that is just a coincidence, but it's more that if we were to substitute this number here into the equation, we would get our result. So have a look at what happens if I do this. If I go p of negative 3. Now this negative 3, it's the opposite of whatever this is. Okay? It's really, you could consider it as if we had, say, x plus 3, I don't need a bracket there, equaling 0, then if we were to solve that, we would get x equals negative 3. So that's what we put into there. Okay, and when I do p of negative 3, well, that's going to be negative 3 cubed plus negative 3 squared minus 5 times negative 3 plus 6. And, well, that first part is negative 27 plus 9 plus 15 plus 6. And that's really negative 27 plus 30, which is 3. So this is a really powerful thing. And, obviously that took 3 lines of working out as opposed to, I don't know, 6 or so, 7 lines of working out. So I think that it's a much better way to sort of go about doing these problems. So the basic rule then for the remainder theorem is that if p of x is divided by ax plus b, the remainder is p of negative b on a. And again, if we were to divide by that ax plus b, it's like taking that ax plus b and putting it equal to 0. So then we can take away b on both sides, and then we can divide by a. So that's why we get this value here. Okay, so that's the remainder theorem. Now the factor theorem is really just a special case of that, because to have a factor, that means that we have to have a remainder of 0. Like if we divide something by something else and there is no remainder, that means that it is a factor. So as I said, factor theorem is just a special case of the remainder theorem. So we could say that if p of x sorry, let's change that. let's make it ax plus b. So if ax plus b is a factor of p of x, that's what I was going for, then p of negative b on a would equal 0. And I guess like this works the other way around as well. So if p of negative b on a equals 0, then ax plus b is a factor of p of x. Now this is really handy for when we actually get to doing the factorizing, and this is something that we use pretty extensively. So anyway, I'll leave the video there and we'll have a look at how to factorize in the next one. See you then.